Right, we're on question 28 and we've got a relationship between a velocity time graph and a displacement time graph. So we can see that the velocity is positive the whole time, and what we need is the gradient of this to be equal to the value of this. So it's a positive value that goes up and then goes down, so we need a gradient that's going to go up and then go down. That's a constant gradient. That's got a negative gradient, so I know that's wrong. So it's either B or D. This goes up, flattens off, then goes up again, so that's wrong. This goes up to a steeper point and then the gradient goes down. But it's positive the whole time, so it's B. Okay, so we've got a ratio here, and I'm going to go over how I would do all ratio questions. At first glance, this seems like it's a really easy ratio because mass only appears once in the kinetic energies, but at closer inspection it's a bit trickier. So let's have a little look at it, shall we? So let's put some things down, shall we? So we've got two things. We've got P and we've got object Q, both being pulled with the same force. And I've marked that P is 10 times the mass of Q. We know that velocity equals U plus AT. And we also know that F equals MA, and we know that K equals half mv squared. Right, so that's where we're up to for now. So annoyingly, that velocity is also dependent on mass, because acceleration is dependent on mass. Right, so what I would do is I would set up the equation so that I can see all of the quantities that could have a difference in the final equation. Then we'll do one over the other and see what number we get left with. So A equals F over 1, A equals F over 10. That's just a rearrangement of F equals MA. I'm not going to bother doing ratios of mass. I'm just literally going to say one's 1 kilo, one's 10 kilos. For V equals U plus AT, the question says it's at rest, so we can get rid of that. So V equals AT. So V equals F over 10t, because A is F over 10, and for Q equals F over 1t. I could have probably got rid of that over 1, but I'm not going to. Right, so we've got that set up. Right, let's stick in, let's just stick in the fact that we know that MP is 10mq, so that when we're putting this in, we can say that K equals half mq F over 10t all squared, and that's because even though that's object P, rather than having it as mp squared, and that was mq, mp squared, mp F over 10t squared, I'm going to put it in terms of Q, because then when I do the ratio, the masses will disappear. Right, and let's do this for kinetic energy for Q. Oops, I have got rid of the one over there. And that is now the two kinetic energies drawn out. So let's put one over t'other and see what it looks like. Half mq ft squared over 100. So I've just multiplied out those brackets there. And what have we got underneath? Half mq, that should just be f squared t squared. Cool. A bit scruffy, but we'll live with that. So what can we get rid of? Get rid of the halves. Get rid of the mq's. Get rid of the ft squareds. What earth have I got? I just realised I'm very sorry. That is complete rot. I accidentally squeezed in an extra 10 there for some reason. So what are we actually left with? That 100 there has got to come down, so we're left with just 10 over 100, which I make equal to 0.1. And that is the ratio of KEP to KEQ. Hopefully that's one of the answers when we look back here, and we can see it is, and that is the correct answer. Okay, at first glance this looks like it's going to be a nightmare, but we know it's stationary, so the total momentum of the system has got to be 0, so it's one of these two. And we want to know the recoil velocity. So we are going to need to just think about that slightly. We don't need to do a proper calculation on this, but I'm just going to do this really just so I can see what the answer is straight away, but I'm just going to tell you how I'm going to get to it. So the bullet goes off with 10 times 100, so it's whacking another couple of knots. So that's 1,000 meters per second. I know that's not the correct units, but that's one lot of momentum. Therefore, the rifle must also have 1,000 meters per second. So that equals the mass of the rifle and the velocity of the rifle. So if I now divide this by the mass of the rifle, which is 4,000 grams, that's why I just kept it in grams, 4,000 grams. I don't even need to work this out anymore. I can see that the velocity is 1 over 4, which is 0.25. As my two possibilities are either 0.4 or that, I now know that it is option A. So sometimes you don't really need to do the calculations properly. You can just sort of work out the ratios, and as soon as you see, you've eliminated it to 50-50, the second you can see that it's 1 over 4 rather than proportional to 4, there's only one answer. Oops, sorry, got locked into that last question. Okay, so we've now got a classic sort of Young's modulacy type question. We're just being asked to work out what the elastic energy stored is. So this is just one for combining equations.